The year is 1.5 billion AD. A gigantic sun rises over the eastern horizon of Earth. If you were to witness this morning 1.5 billion years from now, you would find nothing of the world you know today. Our star is 10% brighter and occupies a vast part of the sky, which, by the way, is no longer blue. The atmosphere, opaque, humid, and stifling, is dominated by an orange and yellow light. Over the arid ground, there is no water, no plants, or animals. Enormous, bright, and scorching. The sun is beginning to die. The beginning of the end. 5 billion years AD. Like all stars, the sun shines because it has a lot of mass. The hydrogen atoms in its core cannot bear the weight upon them and fuse, causing uninterrupted nuclear reactions. Every second, 700 million tons of hydrogen are burned, releasing 386 billion megawatts of energy as heat, visible light, and other radiations. Comparing this to the power of the Itaipu Dam in Brazil, which is 12,600 megawatts per year, makes what humans produce today artificially seem like child's play. Despite such force, the sun currently loses a tiny fraction of its matter. But in about 7 billion years, the hydrogen will have run out, and the star will begin to burn helium. And that's when things start to become a problem. The released energy will be so much that it starts to transform into a red giant. A giant star that pulsates, causing its diameter to vary by millions of kilometers with each pulse. And at this moment, Mercury will be the first planet swallowed and destroyed. The resistance. 7.5 billion AD. The size and brightness of the Sun have reached their maximum level, being 200 times larger, getting very close to Earth. And its brightness, 5,000 times more intense, shows that the star is releasing over the solar system 5,000 times more energy than it did in 2020. The heat on Earth is much higher than that of Venus currently, a heat that is close to 500 degrees. Such a high temperature is capable of melting lead, turning the once blue planet into a true hell. And due to the amount of matter ejected by the Sun, the Earth is becoming even hotter, running a great risk of being destroyed. The fury of the Sun. As the brightness increases, the solar wind launches more and more energy and matter into space. This effect is reducing the mass of the star significantly and, consequently, its gravitational force. A reduction so great that the point at which the ties of gravity became weak, to the point of making the planet stop further away. But even with this loosening of gravity, they have not escaped the solar system yet. For those looking at the planets at this time, they will see a system very different from what it was. One day, Venus has moved to the current orbit of Earth, and our planet to that of Mars. The outer planets, like Jupiter and Saturn, had their orbits doubled, while Uranus, Neptune, and Pluto, there is not even news about them due to the distance they have taken. The end. With the planets spinning farther away, the lone star will agonize for a few more thousand years. In an attempt to reignite the furnace within, it will have expanded and contracted. With each expansion, more and more matter is thrown away, causing the Sun to weaken and slowly extinguish. At this moment, what was once a sun no longer amounts to more than a white dwarf, a small body, with 54% of the mass it had when it was young, now squeezed into a sphere with a diameter 17 times smaller and without the strength to release more energy. A cloud of dust and gases resulting from stellar wear and tear envelopes the solar system. Mummified, what we call a nebula. The planets, except for Mercury, Venus, and Earth, will continue the long and cold journey around what remains of the star. Jupiter and Saturn, however, are caught in a resonance. For every 5 times Jupiter orbits the Sun, Saturn orbits twice. These expanded orbits, as well as the characteristics of planetary resonance, make the system more susceptible to disturbances from nearby stars. And now, 50 billion years AD. These stellar disturbances have made these orbits chaotic, causing almost all planets to escape their orbits, making them wanderer planets. The last and solitary planet that persisted in its orbit is Mars. It will resist for another 50 billion years before having its fate sealed, when finally it too will be ejected by the gravitational forces of the stars passing by. And finally, after about 100 billion years after the Sun turns into a white dwarf, the solar system no longer exists. And the end of the white dwarf that the Sun has become, that will take much more time, so much time. That along with its death, the death of the universe will also occur.